Or good afternoon upon where you are. I want to welcome you to our Stats and Data Nest session sponsored by the American Statistical Association and our friends at North Carolina State. And we appreciate you joining us tonight. We know there will be others that are going to join us as we get started in all of this. And so we want to welcome you. We have several folks from ASA and a couple of folks from NC State, but we're very excited about having Tim Erickson here with us to talk about things CODAP. And so many that have been with us in previous Stats and DataNet sessions have asked so much about that we could not miss the opportunity to have such a great expert and one who shares his expertise with humility so beautifully. And so we're glad that, in other words, he's going to make you feel good about the fact you don't know anything about this, or maybe that you do know, but you need to know some more. So see, he's great. But I'm going to go ahead as he's sharing, and I'm going to share the bit.ly that you'll need in just a second when he gets started. But I'm going to turn things over to Tim. Thank you very much for being with us.
Okay, thank you, Casey, and thanks to everybody for being here. And those of you who are arriving, I'm Tim Erickson. I'm in Oakland, California, where it is not cold by most of the world's standards. It's cold for us because we have to wear long sleeves when we go outside. But that's about as cold as we get here. And but don't worry, later we'll have our own disasters. We'll have earthquakes and fires and drought and things like that. So we have our share. So I am going to mostly be sharing my screen. And so I'm going to start doing that. And I have, those of you who have seen me present before know that I don't usually use slides. I have a few slides because I had enough time to prepare. So let's try this. So here we go. I'm going to share my screen and I'm going to go to some slides just to introduce what's going on here. And we'll do slideshow. Okay, so this is CODAP for novices and practitioners and for Stats and DataNet from ASA. And today is the 10th of February. I also saw another title for this, which was CODAP for the classroom, which I think is another good title for what we have here. And there are a few things that I want to say before we really get started, and I have slides for them to help me remember what they are. One thing is that we're going to have several different modalities here. So we're in this virtual workshop, and it has challenges associated with it. But one of them is where you do things, and another one is where you watch while I demo. And you know, and we all know, that learning works best if you do the things. But if you have only one screen and I'm demonstrating something, and you're trying to follow what I'm doing and actually do it while I'm demonstrating, you have to keep track of all the different tabs so you can go back and forth between what you're doing and what I'm showing you, unless you have great big screens to put stuff on the other screens. So if you do have other screens, you may want to organize things so that you have a browser window on one screen and then you have Zoom on another screen so that you can make that work. The other thing I want to say about that is that we are all adults here and you can decide how much you want to participate. You already know, I think it's going to work best, the most that you can do. But I also want to point out the you watch while I demo. I wish it were not like, this is the problem of lecturing versus actually doing activities. If I lecture to you, we can cover a lot more material. You will not learn it as well, but what you will find out is what sorts of things are possible. And so I will give you some resources to learn more. So if I do something and you say, wow, that's cool, but I can't possibly remember how to do it myself, that is completely normal. And you will see resources about how to go through it more slowly. But we will have you do actual stuff. And so be prepared to shift back and forth between different windows and things like that. Okay, next, we're going to do an introduction to CODAP. And when we talk about introduction to CODAP, in an educational setting, there are two things that are going to happen. One is you're going to start learning CODAP. And the other thing, which is part of what I want you to think about during this workshop, is you have to figure out how your students are going to learn CODAP. Now, The uh, the good news here is that the way that I'm going to have you start learning CODAP is exactly the same as I have students learn CODAP. Why not do it the same way? But throughout the entire workshop, be thinking about what is the student's role, what is the teacher's role, things like that. Okay, the next thing I want to talk about is resources. And there are going to be a bunch of them. So one of them is CODAP has a help and there's a forum and you can ask questions and people are really good and friendly about answering your questions. There's a question mark thing, an icon on the CODAP screen that you'll see, and that's where you would get help. Um, there's a book called Awash in Data that I wrote that's an ebook, and you can do stuff inside the ebook. And if we have enough time and I remember, we'll actually do one of those things so that you can get a feel for what that's like. It starts with the introduction to CODAP, and so you can actually do the introduction to CODAP inside Awash in Data. I don't recommend doing that for this workshop because that's too much screen space. But if we were all together and I could walk around behind you and see what you're doing, that might be a great strategy. And finally, there is all kinds of great stuff from people who are not me, like from Esteem and InStep, that is wonderful resources about how to use CODAP in the classroom and how to think about CODAP and technology as being part of an investigation web. And furthermore, there are links to all these things in the Google Doc. And that's where we're going to go next. And so if you use the short bit.ly link that's there, https://bit.ly, then all caps, CODAP-ASA, that will take you to a different document. In fact, it should look like this. And so I'm going to wait for a moment while you all find yourselves in this place. And probably Casey will have put that link in the chat so you can just click it. But if you need to, see how it's written up there at the top, you can just type it in and it'll all be there. And I see that there are at least 19 people here, but there are 32 people on the call. And so everybody should be in this document. And up at the top of this document, you will see this thing called Phases of the Workshop, and that's sort of my agenda. And so we've already done first steps, a few slides for orientation. And then we're going to go to a blank CODAP document. Don't click that yet. And I will show you what we'll do. And then we will not go into breakout rooms for this, but we will spend a few minutes with you guys just playing around with CODAP, just for a little bit to make sure that you know what's going on. Yeah, let's see. What else can I say? I want to make sure we don't redo too many things for too many people, but let's do that and not actually, let's do the following. I'm going to move this, take a survey. I'm going to put this up here. Before we go to CODAP, go to this survey. I'm going to click on this survey link. And there's a workshop questionnaire, and that will help me know how fast to go through things. But also, we will look at this data in CODAP. And so everybody take this survey right away, and then come back to me, and we'll do the next step. So let's just take, it's 3:09. Let's a minute to do the survey. And if for any reason you don't have access, that means I've got the permissions wrong. And so I'm just going to look at the few faces that I can see, like Ingrid's, and say, hey, Ingrid, did you get it? Did you get that link? Okay, good. So somebody else was there. Thank you very much. Wow. I'm really surprised by the results on TP orientation. Okay, so let's come back together. We have enough data here that uh, I can proceed, and I see that importantly, never seen it before. There's a substantial number of people who've never seen it before. So we will go through the beginning, and just a few people have used it extensively, and I'm one of them. Um, and like that. And a lot of us are teaching people in the 16, 17, 18 range, a little bit up here at college. Most people have not seen me do the data moves thing with ages before, so we will do that. That makes it nice. Apples and oranges, it's pretty even. That's from the Colbert questionnaire, of course. And like me, most people prefer the TP orientation of over versus under. But that's one of my favorite survey questions for groups of students. And there can be important fights about that, about what's the right thing. Okay, so here we go. Here's the workshop questionnaire, but I'm now back here looking at the sort of home page for this workshop, the Google Doc. And I'm looking at 1C, the blank CODAP document. And now I'm going to demonstrate what you do first, and then I'm going to let you at it for about 5 minutes to continue. So I'm going to go to the blank CODAP document. So I click here and I say, oh, go to this untitled document. And this is what CODAP looks like when you first arrive. And just a couple things I need to say, actually, which I should have said before we clicked that. So we're going to look at this for a second and say, CODAP runs in the browser. You don't need to download anything. CODAP is free, so you can give assignments to your students, and we'll talk more about that. And they can take it home and use whatever it is and whatever they've got and do the assignment and all kinds of stuff like that. And you never have to worry about downloading or paying or any of that. There is no way to pay to get more CODAP. Okay? A thing so I guess that's enough to say about that. So I'm now back here looking at this CODAP document, and what should I do? I've got two buttons, open document or browse examples versus create new document. Mostly in my life, I create a new document, but right now I'm going to click open document or browse examples. And there is this list of example documents, and I want you to do getting started with CODAP. Unless you've already done that so many times, you want to do getting started with CODAP too. So if I click getting started with CODAP, come on. Oh, so I have to click open. It was underneath the Zoom sharing thing. And now I'll see this, and it says, wait, figure out how to accomplish each of these basic CODAP tasks. So figure out how to accomplish each of those basic CODAP tasks. I'll give you a few minutes, and then we'll get back together and discuss what we discovered. And I'm going to stop sharing for just a moment. Oh, and while you do it, I noticed that some people have phones. Here's the thing about CODAP. It uses a lot of screen space. I don't recommend trying to actually do CODAP on a phone. You can learn a bunch by being in this webinar on your phone, but you will probably not have a very good time actually doing the activities. Best on a computer, uses lots of screen. So the other thing I'll say while you're working is, I hope you come up with questions while you're doing things. If you're in a breakout room, you should ask the other people in the breakout room. But if you're not in a breakout room, you could put your questions in the chat, and the people who are helping do this will help consolidate those so that I can answer them. But there are enough people that it might be inconvenient, but if you can't help yourself, just shout out your question and I will do my best. But putting them in the chat would work great. And if you finish getting started with CODAP 1, do getting started with CODAP 2, and see what's there.
Tim, if you wanted to share your screen again with that, with the short link, we had a couple of folks
Oh, sure.
just
Yeah,
join, but I'll drop it in the chat as well.
great. Here we go. And if anyone could help me assess whether you're all done, because I can't walk around behind you. I think you might be.
You could raise your hand if you're done.
Yay, okay. A bunch of people are done. Is some. So we see Tina's done, Ingrid was done. Tim's done, great.
Stop.
Someone says they're trying from their iPhone.
Well, it's possible. It's just really hard. I need smaller fingers to do it on an iPhone. Okay, so I'm going to bring us back together. I have getting started with CODAP 2 on my screen here. And I'm going to demonstrate the things that are here on the screen kind of really quickly, but I'll do it with some commentary. So starting students with CODAP, if I give them getting started with CODAP, then they know how to make graphs, and that's the main thing. But the way to think about it that I really like when it says make a scatter plot of height versus age is when we have students make graphs without technology, one of the things we always say is label your axes. And that's exactly what we're going to do. I'm going to put age on the horizontal axis, and I'm going to put height on the vertical axis. And by the way, why does height go on the vertical axis and age on the horizontal? And we could have a discussion about that. I'm not going to ask for answers right now. But one important reason is height is vertical. Now, we know that height is a response to age rather than the other way around, but also height is vertical, and that helps as we're trying to learn what a graph means. The other thing you're going to notice in CODAP is that it's all about dots, and every dot is an individual case. And one of the things to note is, like, let's say I want to find out what's this highest dot. That must be the tallest person. If I click on it, oh my goodness, the table scrolls to the place where the selected case is. So this is a 31-year male who is United Statesian, and he's, well, how much education does he have? More than high school, and his BMI is only 22.97. Okay, so things like that. So I can find out about cases without creating additional graphs or without putting in more variables. And so the next thing is, it says drag a selection rectangle around a subset of the points. Suppose I want to get rid of all of those pesky children. So I'm going to I'm going to right now start above and to the right and drag with my mouse and see how it's selecting things in the table as well. So I drag with my mouse to select all of those. Now, it says hide the unselected cases. Hiding is something that goes with this eyeball. If I click on the eyeball, it says hide selected cases. Oh, no, it says hide the unselected cases. Oh, well, I'm going to hide the selected cases because I'm trying to get rid of the children. And if I click hide selected cases, they disappear. The data have not disappeared. Only the points disappeared in the graph. So we've applied a filter to the graph because we happen to be interested in the heights of adults, say. And because we're interested in heights of adults, we don't want the kids in the graph because they're a distraction. So this is a data move where we say, I want to restrict the data set because I'm interested in something in particular. So we've hid the, oh, well, of course I didn't hide the unselected, but we didn't get rid of them. We can always get them back. Show all cases. Now they're all back. Now I'm going to do that. I'm going to hide the unselected cases. Something went wrong. Hide unselected cases so that I get this check mark. I'm going to deselect all the cases, including the ones in the table. All right. These are all selected. They're blue. To deselect, I can click somewhere else in the graph is a good place to do this. Click. Now they're all orange and it deselected. Rescale the graph. Well, in CODAP, like in Fathom or Tinkerplots, you can rescale the graph. See how if I put my hand over the numbers of the axis, it says drag to translate axis scale. So if I grab this and I drag it, it's going up and down. If I grab the 200 and pull it down, I rescale the axis that way. And if I take the 140 and move it up, I rescale it that way. I can rescale any of these. And now you see I've changed the scale of the graph dynamically. If I were using a TI-84 or something like that, I would have to type in new minima, maxima, etc., and then click go, and now the graph would look completely different. I love this dynamic aspect of CODAP where there's so many other dynamic things as well, because it helps students understand what's going on as we stretch and shrink the scale of the graph. Now, it also turns out that if I'm on a Mac, I can hold down the Option key and it turns into a plus sign. I think it's Alt on a Windows machine. But if I just click the plus, I can zoom in. I can also just zoom in by clicking on an axis. Now it's zooming in. And then when everything is lost and I don't know where it is, this thing in the upper right is the rescale button. And if I click here, it will move everything so that it fits in the graph again. All right.
Tim,
Yeah.
Tim, this is Holly Lynn. Could you magnify your browser screen a little bit? I think it might make, instead of seeing so much of the white space,
Is this magnified for you?
it is not.
Okay. Okay. I will use a different magnification technique. Like that.
Yeah, there we go.
Okay. Thank you. Good idea.
Thanks.
All right. So we'll try to do more things with this in this giant setting. So unlike in some statistics software things, there are these objects, these components that overlap each other. And so if I don't need to see the table anymore, I can put the graph in front of it, for example. So I'm going to do that a bunch because of making the screen better. Holly Lynn made a really great point. Okay, add sex as a legend to the scatter plot. Now I need this here. The way I do this is I take sex and I'm going to drag it into the middle of the graph and drop it. And Andy Rubin, our friend, says she calls this plopping the variable or the attribute. So I plopped the attribute in the middle, and by gum, there seems to be some sort of systematic difference between the heights of adult males and adult females. And in addition, there's a little, looks like people, they're shorter when they're older. And there's a whole bunch of great activities we could do about that, but we're not going to do those right now. Instead, I want to move on and let you do some exploring on your own. But first, what sort of questions do you have about what you've seen so far? And someone who's reading the chat can inform me if there's questions that are there. I don't see questions in the chat. Whoops. So no questions so far?
No questions that we see.
All right. So you're going to have another opportunity for questions in just a moment. So I'm going to go back to our little, see, notice how I'm going back and forth between here and this, and I'm sharing my screen, so I'm not watching Zoom, but I got a little bit of your faces. But here we are in first steps, ABC, we did C, blank CODAP document, as to browse examples. Now, let's look at the famous Titanic data. And what I'd like to do is do breakouts for not very long, but we'll visit them and find out how long. But I'm imagining somewhere between 5 and 10 minutes. And we're going to go to this link here. There's a document in CODAP, and we're going to go there. And your objective is to explore the Titanic data. And I'm going to show you one thing that you might not immediately know. So here we go. This is what the data looks like. Oh, it's good. This has a little legend in this. And so you know that survived 1 is yes and 0 is no. That's the key thing that if you didn't know, it would be important for you to find out. And so these are the 1,309 Titanic passengers, not the crew. And you probably already know things about this data set, but use CODAP to explore it a little bit and see if you could come up with an intriguing claim and a visualization that speaks to that claim. And so now someone will put us in breakouts and I will try to visit you. But here's the thing about the breakouts. You should be talking. One person should be sharing a screen. You don't have to, but I think it's kind of nice if one person shares a screen, you can sort of collaborate with that. And everybody try to do things on your own computer. You may do something different than the shared screen, but it will give you something else to be looking at when you go back and forth between Zoom and the browser. And if that doesn't work for you, stick with your own computer and explore the data.
Tim, before we go into the breakouts, can you just repeat what we're supposed to do?
Okay, so we've got this data set with Titanic passengers in it. And the obvious thing to do, which is a good thing, is to try to figure out who survived and who didn't. So you might come up with a different kind of claim, but look at the data, see what you've got, and see if you can make graphs that speak to this, whatever question you might have or a claim that you might have about who you think survived and who did not survive, and try to come up with a visualization that communicates your ideas well. That are really coming back. And I'm going to first acknowledge that it is really hard to be doing your own thing and to be trying to look at the shared screen at the same time if you only have one screen. And that's not usually the way it is in a classroom unless you're teaching remotely. And so we will just do our best. And I invite you to, if you can figure out how to switch back and forth between seeing my shared screen and your own screen to do as much of it as you can. I hope you can figure that out and make that work. So what sorts of questions did you have looking at the Titanic data? And by that, I mean, mostly we're talking about CODAP logistics and how to use CODAP as opposed to what the truth is behind the Titanic situation. But did you have what did you find out about the data? What's a good claim you could make? And what CODAP questions do you have? And you can put them in chat or raise your hand and someone will call on you. because if you don't have any, I notice some things that are worth showing, because it's the sorts of things that you find out. One thing that people noticed is that you sometimes discover things by accident. This is completely normal and exactly what we hope for. Because when a student discovers that, oh, you can make the points different colors by dropping something in the middle, that quickly spreads to the rest of the class. So, Arlene, you have your hand up. Got a question?
So, one thing we stumbled across was that sometimes it doesn't just graph on one set of, well, it's one set of axes, but it split the graph into quadrants for us.
Ooh.
And I was thinking of when will it do that and when will it not? So we were graphing, what were we graphing? Age versus, no, survival versus sex. That's the first thing we looked at. And we got an interesting looking graph that had 4 different plots in it for us.
Oh, okay. Yeah, yeah. And I wanted categorical. I'm making little notes too of things that I want to be sure to say in this little phase. Okay, so now you've all had some experience. That's a really great observation. And so let me share my screen, and I'm going to do a few things, and you will now recognize them and maybe give you some additional ideas about what to do. So here's my screen sharing button. I'll share my screen. And here we are. Here's the Titanic data. Okay, so here's one thing. Look at how much screen space this takes up, especially because Holly Lynn made me make my screen bigger so that I can't see everything. And I can't see easily all the way across. So one thing you can do is, I want room for graphs. I can make my table shorter, not thinner, but shorter, so that I can reach all these different things. So if I make a graph, look at those cases, see, they're all random. And you said you had sex, and so I'm going to put that on the horizontal axis. And so where you see, oh, there are many more male passengers than female passengers, that's curious. And I'm going to put survived on the vertical axis. And then I get this 4-pronged thing. Now, is that what you were talking about? Okay, yeah, so speak instead of just nod, because I can't see.
Oh, so sorry. Yes,
No, that's okay, good, great. So
that's exactly it.
So this is maybe not what you were expecting, and maybe not the graph that you thought was most useful, though you can see, look, there are more survived females than unsurvived females, and more dead males than live males. And so it does
Yep.
look like there's a relationship between sex and survival. I'm going to undo that. And now, instead of putting it on an axis, I'm going to put survived in the middle. And now that is a different way of rendering exactly the same data. And so a question for students is, which one communicates what you're trying to say better? Now, at this point, a famous German statistics educator, Rolf Bieler, and I will not do his accent, though I have in his presence, and he looked amused, said basically, but what if I want to see the proportions? So let's do that. So here's an important CODAP thing. When I have a component selected, and a table is a component and a graph is a component, there is often a palette over on the right-hand side that's attached to it. If I unselect, I'm going to click over here, now the palette goes away. But if I click on the graph, the palette reappears. And there's only one palette present at any time. So if I go to here, which is the configuration palette, I can say, oh, fuse dots into bars. I like that. And now the dots, instead of being a dot per person, now there's a bar. And if I hover over it, I can say, oh, 682 of 843 of the males, 80.9% are 0, that is to say, dead. Whereas, and now I'm pointing at the ones, 72% are ones, how many are dead? 27% are zero, whereas 80.9% are zero for the males. And so I can do this sort of comparison by pointing and hovering. We would really love to see proportion. So I go back here, and now that they're bars, oh, look at this. I can scale it by percentage. And this is the sort of equivalent of the pie chart that you might want, where we're looking at we're comparing the proportions of females that survived to the proportions of males that survived, irrespective of how many females and males there are. See, if I'm in count, you can see that there are more males than females. If I'm in percent, you can't, but it's easier to compare. And so this fusing dots into bars is the thing that has changed. And now we're back so that every dot is a person. This idea, what is a case, is central to what makes CODAP work, that we will be thinking of every one of these dots we even know her name, don't we? Every one of the dots is a person, a single person, and that is Matilda Petranich. That dot there is her, and she's 28, and she did not survive the Titanic disaster. When we go into bars, when we turn these into bars, when we go into bars is different. When we turn these into bars, we're looking at groups directly rather than at individuals directly. Okay, so that's one thing. Another thing that I wanted to just say, because this will distract students for a long time, but it might be worth it. Suppose you look at the purple and the yellow, the orangey thing, and you just hate those as the colors. The paintbrush is stuff like color. And so if I want to change the purple to this aqua, oh, that's how I change the color, and I can get completely different colors if I want. I can pick them from a color picker. I can change the stroke so that everything has a black circle around it, and I want nothing around it. And I can change the size of the points. Here they're really big, and here they're so small they disappear. Okay. Let's see. Here's another thing. Suppose I just wanted to see if there's a difference in the age distribution between the two sexes. I'm going to put age on the vertical axis. And now we have age and sex and survival. Oh, you know what? Here's another thing that will speak to Arlene. You were talking about where else, we don't have survival on this anymore, right? But where else can you drop things? If I take this and I drop it not on the horizontal or vertical axes, but on the top, it'll say it layout side by survived. Ooh, now I have all the live people on the right and all the dead people on the left, and I see the distribution of age by sex separately. Ooh, which means I could go to this ruler, and there are many things I can do. I can, for example, put mean on. So those are the mean ages or the median. Or I can do measures of spread. I can, give me one standard deviation. I can put in box plots. And so those are four parallel box plots. And by the way, when I have that, you can see that I have the box plot. Do I want to show the outliers? Sure. I have the box plot, but I also have the distribution behind it, which is great to help us understand what the box plot really is. However, sometimes you don't want to see the distribution behind it. And if I go back here to the brush and I make the point 0, now I just have box plots, which is kind of what maybe I wanted in order to say, the distributions are about the same, except for the not survived females are a little younger than the other groups. They're indistinguishable. Okay. So this business of putting a categorical variable on the top or on the right, let's try it. Will it let me do? No, it's not going to let me do that. I'm going to put survived on the right as well. So now I've got survived going up and down instead of left and right. So you can put things on the top and on the right, and it is very easy to make graphics that are so confusing you can't draw any conclusions from them. Someone might have already noticed that if you had, let's see, I'm going to make a, so here's this thing that you should notice is that you have, you can make more than one graph. And so if here, let's make another graph, and I'm going to put age on this graph. If I select all the second class people, they are all selected in every visualization. So those are class 2. Now, this P class thing is treating this as a categorical variable. If I wanted to treat it as a numeric variable, I can click treat as numeric. And now you get this very useless graph. But if you see this and you really wanted it categorical, you can go here and change it back to treat as categorical. Okay. We did colors, we did bins. Okay. All right. I think that's enough of that. If you have no other things that you have questions about.
Tim, there was a question about how would you find the median age of all the passengers?
Okay, great. All right, here we go. I'm going to go back over here and I'm going to look. Oh, here is a graph of all the passengers. Now it happens that I have the second class people selected, but if I go here and I choose median, I just get that one median. And if I wanted this to appear on the screen, I go over here and I say, show measure labels. So median is a measure of center. And if I do this, it will leave this here. Okay. And now if I, for example, take and put it on the vertical axis to make 2 parallel dot plots, I now see 2 separate medians. Okay, so I see 27 and 28. So they're different. Okay. We are running so behind, it's amazing. So we've answered a bunch of initial questions, and I'm intrigued by the idea of going into the next phase. And so many of you are not beginners. This was old hat to you. But I would love to, dare we run quickly through 800 children and teens? I'm going to demonstrate this to you and explain some important things. Because enough people said they wanted to see it again. I was one of the only people who said, please don't show me the same thing. Here we have 800 people. And this is data from NHANES, which is a national health and nutrition something survey. And this is from just before COVID. And here I've got people aged 5 through 18. And what I have students do, and I've got 800 of them, what I have students do is explore the data set, find out things, and they say, ooh, upper arm length and height. I'm going to put height on the vertical axis because I love that. I'm going to put upper arm on the horizontal axis and say, oh, look at that. There is a strong association between the length of your upper arm and the height. I can do stuff like put a least squares line on here, and there it is. Or I can do a movable line. We love movable lines for modeling because I can move it. And as I move it, the equation for the line changes in real time. But I don't want that anymore because we're running out of time. We have to get to the important thing, which is what things do you notice about the data? And I say, oh, let me put age on the horizontal axis. And before I drop it, I want to predict, and I want to have the students learn to predict what will this graph look like. And what they will say is, well, as you get older, you get taller. And so I expect a strong association as well. And you look at it, and indeed there is a strong association, but it looks different and a little weird because it's got these vertical stripes. And the vertical stripes are because all the ages are integers. So unlike the last thing that we saw, which was reals, these are integers. And so every vertical stripe is a separate age. And so then we say, well, let's make another graph and say what else affects height. I think gender affects height. And so I'm going to put gender on the horizontal axis. And it looks like that. And I say, who's taller, boys or girls? So I'm going to put the mean on here. And sure enough, the boys, I mean, we'll even show median, so measure labels. The boys are 159, the girls are 149. And so look, the boys are taller than the girls. Are we done? And the answer is, well, no. This is a terribly bogus graph here because we already know that age is an enormous factor associated with height. So how can I deal with the fact that I now have two variables that are predicting height, sex and age? Well, one thing I could do is I could put sex, plop it in the middle here. And now I see, this is so unsatisfying because if I do this, all the points are on top of each other. I could treat age as categorical. Oh no, now they're alphabetical by number. I can move, by the way, 5, 6, 7, and 8 over here, but it's just going to be a mess because I don't quite have enough screen space. It's all Holly Lynn's fault. She made me have less screen space, so I can stretch it out and I can kind of see what's going on, but that doesn't work. There's a number of different splits I could do, but I'm going to treat these back as numeric and I'm going to come up with a different strategy. Whoops. I did it wrong. I want age to be numeric because gender is not numeric. Gender is categorical. There we go. That's what I saw before. And what I'm going to do instead is the following. I'm going to do a number of data moves. The first thing I'm going to do is I want to look at one age to see what's going on. And the age I'm going to pick is 10. So I've selected all the 10-year-olds. And now I could hide the unselected cases. In fact, that's what I'm going to do that. I'm going to hide the unselected cases. And so now everybody's 10 years old. So age is irrelevant. I'm going to put gender now on the horizontal axis like I did before with the other one. And I see, isn't that interesting? Now the girls are taller than the boys. So over here, we saw the boys were taller than the girls, but here with just 10-year-olds, we see the girls are taller than the boys. So the activity I now do in class is I say, students, you've seen me do this. There are enough of you that you're in groups of 3, and each group is going to get a different age. I want each group to do this filtering thing and tell me what the mean height for the males and females is for each age. You guys do 5, you guys do 6, you guys do 7. We're going to write it up on the whiteboard. And then when we're ready, we're going to come up here to CODAP and we're going to make a new table. So notice I'm going to the tables thing. I'm going to make a new table and I'm going to say the attribute name is, we're going to rename this and say age. And I'll add this button is add a new attribute. I'm going to say male mean. I'm going to do another attribute, female mean. And now that's done. And I'm going to add the data. I'm going to say for 10, the male mean was 143.2, 143.2. For the female mean is 146.8. And you can see what I'm doing here, that I've started this table, and when other groups finish their work, they can add it to the table, or I add it to the table, or they each add it to all of their tables. And then we're going to get some sort of comparison of males and females with age and height. And this takes a long time. So when we get to the end of this, there's this beautiful graph, which I will show you in a moment. But the problem is that it has taken so much time. There ought to be a way to get the computer to help. And that requires a couple more data moves. And so that's what I'm going to show you right now. So I'm going to close this because we don't need it anymore. And we've got this here, and I'm going to, well, we'll just leave it. So here we are, NHANES data. What I want to do is I want to group the data by age so that I can do calculations by each age. The way I do that is I grab age, and instead of dragging it to a graph, I'm going to drag it leftward in the table. And so I'm going to take over here like this. I'm going to drag it to the left. And now you can't really tell, but if I select the tens, what this is this group here, the shaded group, which I've selected the 10, the shaded group over here, these are all the 10-year-olds. And I go down to here, and there's a total of 51 of them. Okay, so that's all of the 10-year-olds. And then it's followed by all of the 13-year-olds. And if you are made anxious by the fact that this is not in order, which I don't blame you, if I click on age, I get a menu. Oh, this is where I can put a formula, but I can also sort it. So I'm going to sort it so that I now have the 5-year-olds on the top, etc. And so now I feel much better. Now here's the next thing that I'm going to do. I'm going to make a new attribute, a new column. I'm going to do that right here. Let me stretch this out a little bit and see if I can make it clearer. There. I'm going to make, you almost saw this. There's this plus sign under here. Add a new attribute. So I click here. I'm going to say mean height. And I can go here and click on mean height. And this is where I get edit formula. So instead of like in a spreadsheet where I type equals, I don't type the equals, and I just put the formula that I want. And this is going to be mean of, and I'm going to start typing height. And it says, oh, height is with a capital. If I click that, oh, look, it turned magenta, which is the color that says it's an actual attribute. And I apply it, and it calculates the mean height like of all the 5-year-olds, and then all the 6-year-olds, and so forth. Well, this table here, this is first-class data. So if I take age and put it on the horizontal axis, and I take mean height and put it on the vertical axis, I will get a graph of mean height as a function of age. And look at the story that this tells us. This is kind of like what we saw when we had the whole graph. We have height there. I'm going to put age on the horizontal axis. So this is individuals' height, whereas this is groups' mean height. And it does look kind of the same. That is, it goes up and then it kind of sort of levels off. And you can really see that here. But we've missed gender. We lost gender here. So here is the mind-blowing, amazing, wonderful thing. I have grouped these things by age by moving it to the left. I've made a hierarchical table where at the top edge of the end of the hierarchy are all these different ages. If I drag gender and put it next to age, I'm going to get a Cartesian product. I'm going to get every combination of age and gender, and it will calculate the mean height for each of those combinations. 5-year-old females, 5-year-old males, 6-year-old males, 6-year-old females, and the graph updates to correspond with this, so that now we see a completely clear picture. Both groups, boys and girls, grow kind of the same. There's a little time when the girls are a little bit taller than the boys, and then the age 12-ish, the girls stop growing and the boys keep growing for another 2.5 years. And so when they're older teenagers in high school, the mean height of the boys is taller than the mean height of the girls. However, because we're in CODAP, we still have all of the data. And if we really wanted to see it and we wanted to put gender in here, we could see that there's, in fact, let's get just the 17-year-olds, hide the unselected cases, separate this by gender. Can I grab it from here? I think I can. There we go. Oh. So we see that the boys are taller than the girls by quite a bit, but there are still tall girls that are taller than the average boys and really shrimpy boys that are shorter than the average girls. So we can see, and this is so important for statistical learning, that a measure of center might give you a really clean and compelling story that's very important and useful. But when you use measures of center, you actually lose some information. You lose information about the variability. And a thing that I love about CODAP is that I can show both of those at the same time. And I can help students do this wonderful thing with the measure of center, with the mean, and not lose sight of the fact that the variability is a real thing that they have to pay attention to. Okay, so that's about this thing that I have called data moves. One thing we did was we filtered. We looked at just 10-year-olds for a little while, and the 10-year-olds, looking at 10-year-olds helped us see what we wanted to do. We wanted to compare means. Then we grouped things by, in this case, age and gender. And then we summarized. We created a summary measure, an aggregate measure, in this case called mean height, and we just wrote a formula for it. So those are three important moves that we do. And the thing that I want to just point out here from a data science point of view is look how frigging multivariate this data set is. There's all kinds of stuff, and there could be more. When we teach regular stats, because we have a particular curriculum that we're trying to teach, we say, okay, it's time to do the two-sample t-test, okay? I will give the students a data set that's perfect for that. They don't have to find exactly the right data that will make that test the most relevant thing in the world to do. They need that to be prepared for them. But here, we're looking at real, genuine data where we can discover anything, but we might have to do some filtering and compressing and things like that ourselves. That is an important data skill, which for years we have completely ignored, and we haven't let students do it themselves because we've given them sanitized, slightly pre-digested data for good reason. But now, because we have tools like CODAP and like other important technological tools that can look at larger multivariate data sets and let them do some of this machination themselves, I think we owe it to them to have that opportunity. I was talking to one person in a breakout room talking about, oh, after the AP, if you're teaching AP stats and you feel compressed by that Acorn book, after the AP might be an opportunity to see what students do. I had the privilege of teaching a non-AP stats course so that I had an entire semester to let them do stuff like this and do different projects. And that worked out actually really, really well. Let's see what else we have to get to here. I'm thinking that we might not have time to do 1,000 Iowans, but there's another thing I would love to demonstrate to you to do, and it also gets to on this page down at the bottom. Casey Maddox, who is sort of in charge of this, wrote me a whole bunch of questions, and so here are the framing questions. How do I get a data set into CODAP? Well, we've done some typing in, we've done some formulas. We could do simulation. We need to learn how to import your own data. And that is most often done as a CSV. And I want to show you that. We want to use Google Forms and Google Sheets. We have a Google Sheet. We'll do that. We could use a data portal. I could show you that. And man, it's quarter after almost already. Let's see. How do I change graphs once I've created a graph? Changing what's on a rescaling axis. We looked at features in the palettes. Oh, we have to do this. We have to do the sharing. Okay. So what I want to do, an important next thing to do is to say, what were the survey results? So here are our survey results, and we can view it in Sheets. And here is, there's our answer in Google Sheets. Wow. We've got all of this material. This is our survey. How do I get this into CODAP? Here's what I do. I'm somewhere in the sheet. I do Control A for select all. So you can tell I selected it. I did a copy. And now I'm going to go get a new blank CODAP document. And it says, I want to create a new document. And now here is the thing that I have done more in the last year than before. I go to tables and I say new from clipboard. Because I copied the sheet to the clipboard, it copies it in CSV file. So I'm going to do new from clipboard, and here is the data that was in that sheet. And so I can say, what's my CODAP experience? Okay, and how does that match with my apples or oranges? Okay, it looks like people with only a little CODAP experience really tend to prefer oranges. So this is the kind of thing you could conceivably do. We don't have a lot of things with correct TP orientation because there are only a couple people who got the wrong answer. Let's see. Anyway, so we got the data into CODAP very easily. I want to, let's see, show you a different. Here are 1,000 Iowans as a CSV file. Okay. We're not going to study them, but I'm going to open it. And I have this thing, and I'm going to download it. Okay, so I'm going to, and there are lots of different places you would end up downloading a CSV file, but here it is. And I'm going to put it on the desktop. And I'm going to say save. Oh, I've already got one because I practiced this, but I'm going to replace it. And so I have this 1,000 Iowans, lots of attributes. And can I do this? Okay. We've made it slightly larger. So here is my Finder because I'm using a Mac. And let me go to this thing. I'm going to make a new document. I'm going to say create new document. Now I'm not going to go to the tables thing. I'm going to switch to the Finder. So I've got it set up so that I have this document over a place where I can see an empty spot in CODAP. So this is a CSV file, any CSV file. I drag it and I drop it. And there they are. So I have now 1,000 Iowans and a huge number of attributes. So I've got state, age, sex, marital status, education, recode going on, how many weeks worked, all kinds of things. It's a mess. So one strategy is I can go here in this table and see up the upper left, it says switch to case card view of the data. So now I can see more attribute names when it's vertical, but I'm seeing actually only one case at a time. So this is a 48-year-old female, had 3 in her family. The total family income is $22,770. And this was 2020. Did they move? She was born in a US state, things like that. And I could look at the very next person by going like that. Here's a 79-year-old male and so forth. And now, of course, I can make graphs by going like this. And there are 1,000 people from Iowa by age, and I can look at the sex distribution, and are the females in fact older than the males? Can't really tell from this, but we could do some analysis. Okay, let's look back at the list of questions from Casey and see how we're doing, because we want to get to some questions at the end. Here are these questions. Oh, use a data portal, Google Forms. We did a data set. We did Google Forms. We haven't used a data portal, and I want to do the AI thing. Let's do a data portal. So I'm going to go here to the Titanic data. I'm going to create another new thing. Oh, because it's got Titanic in its name. Okay, I'm going to create a new document. And actually, let me do something different. We're going to do this, but I want to show you, CODAP is going to come out with version 3 in a moment, and it's got the same layout and everything. It looks a tiny bit different, and it's substantially faster with larger data sets. I'm going to go to the plugins, and I'm going to say getting data. Let's do daily. Oh, so many things we could do. Let's do NASA, Earth, Air, and Water. Let's, Rebecca, what city are you in? Are you in Anchorage or Juneau or someplace like that?
I'm in Anchorage.
Okay, Anchorage. Anchorage, Alaska. Okay, so you're at 61.2 latitude there. And we've got a whole year's worth of data, and we're going to get sunlight temperature, water availability, and let's just get the data. Some data requested are not available. Okay, that's fine. And I am in Oakland, California. And let's see if I get the data, and I'm going to add that. Ooh, so look, it's already hierarchical. I've got Oakland on the left and Anchorage there. And we're going to look at Raleigh, North Carolina, and get the data. And so now if I make a graph and I put date on the horizontal axis, let's see what I've got over here on the right. Oops, whoa. I want to stretch this out a little bit. I want sunlight angle, though that's going to be very trigonometrical, isn't it? UV index, solar, come on. Where is the temperature? Okay, maximum air temperature. Here we go. Put that on the vertical axis. And now we see three things. We want location as our plop. And so here you can see this graph. I'm going to make it nice and big. So Anchorage is in orange, and you can see that it gets much colder in Anchorage than it gets in these other places. You can see that Oakland in purple has a smaller range of temperature than other places, and that Raleigh gets kind of beastly in the summertime, but is substantially colder than Oakland now. And we could look at any number of things where, for example, if I wanted to get sunlight angle on the vertical axis, this will not have nearly as much variability, right? So that's examples of different kinds of data. Now, we got these data from one of these things, a data portal. And there are other data portals, such as the microdata portal, where you can get information about thousands and thousands of Americans from the US Census. We can get the NHANES portal. This is where the heights and the weights of the children came from, and things like that. So that's another way of getting things. But here at 421, I want to just do one other small cool thing. I'm going to change to Claude. And actually, let's see, it's already right here. What I did was I said to Claude, that was great. Hey, I want a CSV file with 50 states plus the District of Columbia, but I want population, area, number of miles of highway, number of vehicles registrations, name of the capital, latitude and longitude of the capital, the region. This time, please include Rocky Mountain. Oh, and median income. So I went to an AI and asked for a CSV of the data that I wanted. So I'm going to copy that, and let's go, and we're going to make another new CODAP. We're going to leave the site. I'm going to create a new document, and I've got it as CSV, so I'm going to go to table and new from clipboard. And here's all this information about median income, highway miles. So I want to know how many vehicles there are per highway mile in each state. So I click this plus sign and I say V per mile, because I know the number of vehicles and I know the number of vehicle registration. I know the number of highway miles. So I just divide the two. And now I can make a graph of vehicles per mile and see what we've got. Now, one thing we're always interested in is outliers. Who do you think has the most vehicles per mile? So I just click here. Oh, Hawaii. That's interesting. There's California and there's the District of Columbia. I figured District of Columbia would be high, but that's interesting. Okay, so Hawaii has the most vehicles per mile of any state. And just by the way, if I change the name of this to latitude instead of capital latitude and longitude, latitude and longitude, or lat and long, are special names, because if I look at a map, sorry, I clicked it twice, it will show me the locations of the latitudes and longitudes because I asked for the latitude and longitude of the capital. So if I take region and plop it in the middle, I see it said, oh, look, it said Southwest and Mount. So there's only two in Southwest between New Mexico and Arizona. If I wanted to put those in Rocky Mountain, watch this, we're going to recode this. I'm going to take region, drag it to the left, and now, Southwest, I want to get rid of. I'm going to just edit this, change it to Rocky Mountain. And now they're in one category, and now these states are in the Rocky Mountain area. And I could compute, for example, the total number of vehicles per mile in each of these regions and see how they are different, or compute their median income or things like that. And all because I just framed a question to Claude to give me the relevant data. Now, I'm going to stop sharing. I will go back if you have questions. We got just a few minutes for things you might want to fill in with what you've seen and heard. Any reactions? How many people did we lose? Now we've got a lot of people still. This is great. I appreciate your being here at dinner time, especially if you're here at dinner time.
Tim, what would you suggest? You had a lot more things on your agenda there, or your homepage, as you called it.
Yeah.
What would you suggest about the likelihood of successfully maneuvering those other parts of your page that we didn't get to at your own leisure later on?
Okay, so great question. One thing for at your own leisure, you are certainly welcome to try, and people have different levels of comfort with stumbling through things that are not entirely obvious what to do. Some of the things on there, like the traffic simulator, you would need me to tell you what, actually, you could probably figure it out, but you would need me to tell you what to do. However, I'm going to share my screen and give you a little tour of one of the resources, which is a thing that will be good to do. So if I go back here and I say, ooh, where could I learn more about all of these things? Of course, you could go to InStep and Esteem, but I'm going to show you my thing, which is Awash in Data. And so I'm looking at Awash in Data here, and I'm going to open up this link. So this is an ebook about data science-y things and how to do stuff in CODAP. And so the opening lessons, here are 6 lessons, number 2 through 7. These are what we did they start with 800 children and teens. This is what we did with the children and teens. You want to go over that again? You can do that. Here is this section is about data moves, about filtering, grouping, calculating, summarizing, joining, munging data. What do you have to do in order to prepare data for use when you've got it from the internet? Things about visualizations, this graphing tips that I gave you some of. Other CODAP topics, types of attributes. Oh, I didn't talk about sharing. So you want to make something for students that it's a particular form, share is the thing, and this will teach you how. Coping with screen space, modeling with functions, dates and times, maps, adjusting for season and things like that, how to use plugins, small projects. These are a bunch of projects that I did with my students, and another one that I've come up with since then, Raw Vermont. These are projects that you can do yourself and you can give to students and things like that. Issues in probability and statistics. There are a bunch of things here that are about randomization-based inference, bootstrap, scrambling, things like that. But also, you can do traditional tests like t-tests, and you can do logistic regression and other stuff. And things about different data portals that we have and other tools that we might use, like Simmer, which is a block programming environment for making probability simulations, and Arbor, which is about classification and regression trees. And we are so close to the end. Oh, I'm so sorry I didn't show you sharing. So I will just do the thing here. Suppose you wanted this. I'm going to go to, I'm going to say share, get link to shared view, enable sharing. I'm going to copy this. It's been copied to the clipboard. I'm now going to go back over here to this thing, and I'm going to say links. Links. Here's our shared link. If you click that, you will get my file that was on my screen. The key takeaway is if you set up and I'm going to now stop sharing so that you can see my face while I make this final point. If you set up a data set to be exactly the way you want your students to start with it, like you've set up the graph you want them to see, you've done a couple things, they don't have to do it all from scratch. If you set it up exactly the way you want, you make that shared link, put it on a place where they can find it, like if you have a learning management system, you do that, or the Google Doc that you've prepared for your class, and they can start right there. And each student gets its own separate version of it. So for my students, they start with mine. When they get done with their work, they make a shared link, and that's what they turn in so that I can go to their document. So sometimes I say, no, you have to make a PDF or a Google Doc or something like that. But sometimes they just turn in the shared link to a CODAP document. So.
Well, Tim, we're going to interrupt.
Yes, we have to stop, sadly, I'm sure.
I know. We have enjoyed this so much and learned so much out of this. I use CODAP many times, but I always learn every time I'm with you more and more things. So we appreciate you giving us the bit.ly link so that people can go back and explore, and especially your Awash in Data link there. That's going to be so helpful to us.